So we have this initiation set. So that's places where it's, let's say, legally reasonable to actually execute this option or this abstract action. Similarly, we have termination sets. And a termination set is not the set of states where an option may be ended. It's actually a generalization of that. It's a set of probabilities. So it maps states to a number, which is the probability that the option will end in that state or can end in that state.
I think that makes sense. So they're both kind of sets, but this is kind of a more soft, general kind of set. And is it saying that no matter what, when the option gets to one of those termination states, a coin is flipped, and if it comes up heads, then the option's done?
I think from the sort of from the point of view of the person sitting outside the option, yes. Inside the option, it doesn't have to be quite done that. It's not quite done that way. It's not like the option is running and it's always flipping a coin. This is more sort of a way of describing the fact that something can end in a particular state. Now, of course, you could turn this into a set by putting a probability of 0 over all the states where you don't want it to end and having a probability of 1 exactly where you want it to end.
I see. So that's a sense in which it's a generalization of that idea.
Right, exactly. But basically, I'm going to execute this action starting from one of the states in set I, and it's going to run, and it will end up in some state when the option terminates, and this gives me a probability of it being in one particular state or the other. So all an action is, right, is it's, you're in a state, you take an action, and you end up in another state. But since we're talking about these temporally abstract options, things that happen over time, we need to know what's happening inside the option while it's running. And we already have a term for that, and it's called a policy. So here we have a generalization of the way we've been talking about policies anyway. Policy is more than, within an option, a policy is more than just a mapping from states to action. Here, it's a probability of being in a state and taking a particular action. But again, we could turn that into a normal policy as we've mostly been talking about it by just having a probability of 1 over the action that we're going to take and 0 over the one over everything else, and then it is just a direct simple mapping from state to action.
Like a deterministic Markov memoryless policy.
Thingamajiggy, yes, exactly right. But anyway, this is a formalism, but I think it's sort of is just trying to capture this idea of, as you say, kind of a procedure or a function that runs. There are places where you can execute the function. There are states where you will end up after you've executed the function, and there are things that are happening inside the function. The code itself is the policy. It's the actions that you're going to take and the states that you're going to see.
Okay.
Okay. So let's see what we can do with that.